Welcome everybody. Good morning, good afternoon, depending on where you are connected from. Today, I wanted to go through some of the things related to best practice needs, challenges, and fundamentals for a proper deployment using AWS multi-region. And I wanted to explain what the benefits are, use cases, and when to definitely use this as an approach for your customer, and then when this is not uh, something that should be used. So I wanted to walk you guys through some of the key areas you need to consider when you are developing and building a multi-region with AWS, right? So the agenda is going to be the following. I wanted to walk you guys through the reasons to go with multi-region deployment, and why not to pick up this approach depending on the a few requirements that I'm going to be explaining to you in a few minutes. Some alternatives to multi-region deployment, uh, what the multi-region deployment architecture approaches are, and how we can simplify to to make the most of these architectures depending on the customer requirements and also the use case. So, of course, growth is top of mind, and things like global expansion and also customer experiences are some of the things we wanted to provide when designing and while working on developing a new customer architecture. So, let's say we have a fictitious scenario where we have a gaming business which develops a mobile gaming applications that will be accessible to a large number of consumers worldwide. And on top of that, the business requires replication and complete support for multi-master rights. And in addition to that, the organization aims to guarantee that app users experience minimal latency and reliable performance. These are the two things, right, that we wanted to provide, and we have common requests as the one I just said, where we have multiple consumers worldwide. They are geographically uh, available at all different regions. We need to provide replication and complete support for multi-master databases, is, uh, sparse it across the regions. So the question is, does this necessarily mean multi-region deployment with active active is a requirement? The answer is no. And I'll tell you why the reason for that. Sometimes it's yes, sometimes it's no, and sometimes it depends. So before we can dive deeply on this topic, we need to determine whether or not we should go with multi-region, right? So the first thing that we need to remember is that there are a few challenges or caveats, if you will, while working with a multi-region deployment. The first thing is that the problem with those conventional disaster recovery solutions is that sometimes they are, when they are not used, that represents a lot of waste of money, and they fall out of sync eventually, which means that this will increase complexity, also costs, and issues with data sync. So this is one of the common requirements, one of the common issues that we find across the board when working with multi-region deployments. But what are the main reasons to go with region. Of course, we need to ensure we are going to be providing the best experiences possible to our customers with solutions with consist of best practice to provide business continuity, disaster recovery. We need to provide solutions that improve latency for end users that are geographically distributed across different regions. Also, we need to make sure we are meeting with legal and data regulatory compliance requirements. And these are the common three points or areas that we need to consider when designing multi-region solutions, right? And also on top of that, when talking about multi-region, there are different approaches that I can go with multi-region. Sometimes we don't necessarily need to do an active solution. Sometimes we can go with a hard standby or some intermediate solution that to address and to tackle the issue. So just a few things, right? To go with multi-region, sometimes users connecting from different locations, as you can see here, from Europe, across the US and Asia Pacific. And this is the kind of the thing that we usually to drive the need for this sort of implementation. But keep in mind that designing multi-region is not like a black or white. So as I just mentioned, there are lots of things that you need to consider when to pick it up or not a multi-region solution. And there is a kind of decision diagram where the mission is to kind of map the common scenarios where you're going to find when working with customers. Sometimes we can provide high availability within a single region just by leveraging the multi-availability zones. And for a specific customer budget and use case, that could be more than enough. But for others, as the user case that I just mentioned, sometimes this is not. And we need to determine what the best solutions are, considering things like cost, complexity, business use case. So depending on the point, sometimes a read-only solution would be enough. Maybe we can go with multi-region by leveraging an approach where I have all the rights done through a global approach with all the reads done locally instead. With that in mind, I'm going to walk you guys through some of the aspects required to do that and which solutions and tools and uh, things you need to consider to properly determine which is going to be the best solution. So just keep in mind that multi-region architecture is different than multi-region active, right? And the question is, how do I design for multi-region business continuity? That's the first thing that you need to consider more than anything. Before you get started to determine if you're going to go either with a active or a hot standby or a different approach like a pilot, you need to determine which one you're going to be using. So and the first thing you need to consider is that the key areas. This is the first and the key thing to consider. So what are your RPO and RTO requirements? So you probably ought to be familiar with this terminology, right? So one stands for the amount of time required to recover your systems after the system goes down, and the other represent the data loss, the recovery point. So how much what is the amount of data, what is the volume of data that is reasonable to lose as a result of a downtime. So the mission is to determine what your KPIs are when it comes to these two key things, and align with your business continuity planning, right? Which is a process where a company undergoes to create a prevention and recovery system from potential threats or disaster or even cyber attacks. So these are the key things that you need to keep in mind. And then proceeding on this track, there are a few strategies for business continuity, right? So you can consider like a big backup and restore, where usually the RPO takes hours and RTO could be done in 24 hours or less. And you can working with data applications, and you can do basically point in time backups and just restore the data when necessary to recover from a disaster. Sometimes you need to go with something that is more sophisticated, but we incur some additional costs. So you can go with pilot light that usually the RPO is in minutes, and the RTO is in hours. So pretty much this kind of solution, we are going to replicate your data from one region to another. For example, you can do that with S3 data replication, or you can use a copy of snapshots from either RDS or Amazon Aurora, and copy those snapshots to a different region, and you can go with that with a pilot light. Sometimes you're gonna you go with something even more sophisticated with a warm standby, where RPO needs to take only seconds and RTO is gonna take minutes. So you need to maintain a scaled down but fully functional version of your workload, always running a disaster recovery region. And after all these options, if that's not enough, you're gonna need to a multi-site actives, where the RPO is nearly zero and the RTO potentially zero. So which means that you're gonna have reads and writes done locally, and then you're gonna be to working with synchronization. But the drawback and the downside is that you're gonna need to deal with race conditions, and you're gonna be you should be working with strategy to tackle this. And I'm gonna be walking you guys a few things to consider while designing your application, even from the application or the database perspective, and also on top of that, going beyond with some best practice for networking design. But just as uh, a recommendation here, you need to kind of determine this, where are your key metrics, your key KPIs for both RPO and RTO, and considering your the costs and your customer budget, as well as the use case, you're going to be determining that, considering cost and complexity versus length of service interruption, and also data loss before service interruption. And then you can pick up any of these four strategies depending on your customer solution, right? So this is one of the things. So take a look at this line for the RTO and the RPO. They will vary, right, depending on your customer project, customer requirement. If they wanted to go global, or eventually if they need to leverage a new product or services in a single region, they maybe expand the course of the next year. So you can work in a roadmap to take your customer to the next level, depending on their needs. And why I'm saying that? Because this is the most, more than anything, it's important to understand this to determine which sort of applications you have. So one of the most important parts of a good disaster recovery plan is to understand the importance that each application has within your organization. As you can see here, you can categorize your applications with tier one, tier two, and three tier, and so on. That's basically an example. So you can classify critical applications versus non-critical applications depending on the site failover time versus data loss, and also determine which ones you should pick up depending on the customer requirement. And after you determine which is the bucket where your application or use case is gonna be put, then you can come up with a strategy, right? So this is basically backup and restore with multi-region. This is, of course, is the most affordable, as you can see down in this deck. So usually the downtime, RTO, and data loss, they are higher than other solutions, but the main advantage is that uh, they are more affordable, and sometimes that they could be a good fit depending on your customer requirement. And just a few examples on things you can use, like using S3 with cross-region replication, or even Amazon Glacier to do that. So the data is stored with higher durability in multiple locations, and that could be enough. And then whenever you need to fail over to a new region, you just need to restore that backup, and you can go from there. Also, there is the pilot light. There is a multi-region uh, strategy that allows the scaling of redundant sites during a failover scenario. So let's say in this case we have the web server with multiple application servers and database master and the database replica. So um, you can do that with RDS. You can have something more sophisticated with RDS when using, for example, read replicas, or if you wanted to do even something even more sophisticated, that's going to be the next scenario that I'm going to be explaining. But at this point, you can basically uh, do synchronization of the database synchronization using read replicas, for example, and that could be an approach to to improve your RTO, for example, or your RTO. And in case there is a failure, you can basically redirect traffic by using Route 53. That's a kind of approach. And also, you can have um, warm standby, where you're gonna have, as opposed to, you're gonna have multiple web servers that is active, and then basically you need to stand that environment in case of a failure, and then all the things would be pretty much in sync. And it's gonna take just a few minutes to stand up the whole environment, and then you can move you can redirect traffic, and you can move your customers to connect to that specific region. But the question is, how do I design a single region to multi-region active? So before we dive into that, we need to take in consideration a few things, right? So we need to speak about tolerance for networking, right? So we have region A and region B, and then we have the AWS backbone. And the first thing that we need to consider is that the first concept and the first element is that any problem in one region should not lead to failure of the application in another region. So this is a fundamental while designing the application. The second thing is that it should aim for regional independence for request serving that we lead to minimal blocking APIs or database calls from one region to another. So we, what I'm talking about, what I mean by that is that sometimes you have asynchronous requests versus synchronous, and then you need to try to maximize that as much as possible, right? And when there is a degradation of service, in case of network connectivity, that should be done uh, in a way that this would not impact the other services. So when it comes to data replication requirements, what are the basic ones? So we need to think about the first thing. Does all data necessarily need to be replicated, or just a portion of the whole data, the whole amount of data? That's the first thing. And as I just mentioned, does that need to be done in a synchronously or asynchronously? What is the approach that I should follow? Because that would have a huge impact in terms of cost and complexity. And all the data need to be replicated continuously, or that could take some time. And on top of that, you need to classify your data. So let's pick up an e-commerce workload as an example. You're gonna find like the purchase record, all the other records. You're gonna have HTTP server logs. So you're gonna have a multitude of different types of things. So you need to consider which ones are the most critical for your business, right? And of course, the order records are usually low if compared to the HTTPS logs for sure, but they are highly critical for the business as opposed to HTTPS and click streams that are not as that critical for the business itself. And why I'm saying that? Because you need to determine which portion of your data, if the entire portion of your data, just half of that, or a specific percentage of that will be replicated, right? So let's say in a fictitious scenario where we have region A and region B with an application server in a database, and all the writes are done in a region way and then replicated to region B synchronously, right? And you have the acknowledgement and then we reply. That will impact or affect the overall customer experience, right? Because the customer needs to wait until the data is fully replicated into the second region, as opposed to in a sync architecture where right after the customer places post the request, it receives the acknowledgement, then the replication is done in just a matter of seconds or even milliseconds, as you can find with Aurora global tables. So there are uh, pros and cons and for each of them. So you need to determine which ones are the best depending on your architecture. But the point is, an ideal replication system should have should report replication lag, as well as the offset report record offset, and finally be able to retry those records that failed, right? So this is the common request. And in order to address that, we can go with a few different approaches. I'm going to guide you guys through this process in the next slide. So this is the first one, where we call this as the read local and write global. So let's say we have a region that is in US West U and another one in the second region in the Asia Pacific. So in this case, all the snapshot synchronizations for the EC2 web application database are synchronized, and we have database synchronization, for example, with read replica. So let's say user in San Francisco, they are doing read, and they are redirected to do reads in the US West U by the Route 53, and users in Taipei, all the reads are redirected to be done in Asia Pacific Southeast one. But all the writes will be done only in USU. And that's a great approach because usually, of course, there will be some latest, but that will simplify a lot because you can leverage solutions like RDS read replica, or even going with something more sophisticated like global Aurora global tables, or you know, you can, for example, promote a read replica in case there is a failure. There are multiple ways to address this, and they are available out of the box, so you don't need to implement that process yourself. But there are other options where you do some read local, and your write is partitioned. So, for example, you have again US West U and AP Southeast 1, and there is synchronization between them. And users in Taipei, they do read and write locally, but sometimes that user will travel and visit LA, and the read is going to be redirected to be addressed by the infrastructure in the US West U in the West Coast, but and also the write's gonna be done in shards using the different application layers. So you can leverage different approach for that using kinesis, or even in a combination of, for example, API gateway, DynamoDB, global tables. You can mix and match some of these components to come up with a full solution. And also there is the option to read local and write local. And for that particular one, a good approach would be to leverage things that are available out of the box, like DynamoDB global tables, because it allows to do write and read at the same time with master database. So you don't need to think about synchronization because there is a infrastructure that replicates the data in just a matter of milliseconds. So pretty much there is virtually no lagging between these solutions. Also, you can consider to use global tables for that because you can do keeping consistent between the regions. But in that case, the best approach would be to do read local. I'm sorry, to write global and read local, right? So there are a few things that we need to consider. And I wanted to, for example, when there is an updated object, there will be some sort of a race condition that you need to think about. So sometimes you need to design your application for eventual consistency, right? So how we tackle that, and that will be introducing some additional complexity. And we have a few options to tackle each of these. So let's pick up a context where we have a SaaS multi-application. Let's pick up, for example, gaming applications or media applications, financial applications, whatever. And we have multiple users spread across the globe. They are scattered across the globe. They are distributed. They need to connect from different regions and have different experiences. Sometimes we have users, users in different regions that need to connect to the database only to run reports and some data analytics. They need to extract data or do some ad hoc reports, and then eventually um, a Aurora global database or a RDS with replica could be an option to just replicate the data, transfer it to the business, and then you can just plug for example, a QuickSight or Athena, or eventually you can connect with your specific data analytics solution with a data warehouse with Redshift and or whatever service you are using. But the point is, so the first request is to have disaster recovery. So you can pretty much redirect users across regions. So this is, I just spoke about this unidirectional data replication between region. Uh, for the data residence requirement, you can just balance between the regions depending where the users are connecting from, as well as some specific requirement. There is no data replication between regions. But there are some times where there are data residence requirements, isolated mirror deployment, and then you can leverage solutions like EGS. I'm sorry, you can Lambda with CloudFront, Edge Lambda to route traffic instead of using Route 53. You can use that, for example. And also you can use active deployment where we have bidirectional data replication between regions. But you need to deal with some race conditions. But wait, what are the options that to tackle that? So given the low latency user experience and motivation, what are some of the options and alternatives we can use while working with our customers? So the first thing is that, of course, you can leverage CloudFront where we have multiple points of presence across the globe. It's going to be leveraged the AWS global network. It's a good approach when you're using either WebSocket or HTTP applications. You provide COS termination at the edge. But eventually, when you have applications using sockets or different networking requirements, you can leverage the global accelerator or combining this with networking load balancing. And I'm going to be explaining in a few minutes. So the global accelerator, so basically they are static IP addresses as fixed entry point. Sometimes they are referred as bring your own IP. The point is that they improve performance for TCP and UDP traffic. So uh, this is a solution when you are dealing with these sort of applications, and you need to move any point between AZs and regions with no changes to client or DNS configuration. So this is a important thing. And also you can leverage Lambda at the edge to drive redirection across different services depending on the type of services and things, and in case you wanted to implement any specific business logic for the redirection. But if none of these options are good enough, what are the we will go with active, active. And what are the options we have for that? First thing, as I just mentioned, you need to choose the right tool, right? And in order to choose the right tool, I just spoke about Aurora, RDS, Aurora Global Tables, DynamoDB, Global Tables as well. And but first thing first, we need to determine what is the shape of your data. We are talking about non-SQL, key value, relational database, a document database, a graph database. And on top of that, what are the application's access patterns? So is it high throughput and low latency? They are heavy on reads or they are heavy on writes. And what are the consistency model? They need full consistency or eventual consistency is enough. Uh, how should in addition to that, how should concurrent updates conflicts be resolved? So we need to think about the last writer wins versus first writer wins and etc. So we need to determine which would be the scenario in order to determine which one would be the best fit for our case. So let's work with use case number one, where the shape of the data is a key value and the access pattern is high throughput, low latency, and heavy on reads and writes. And the consistent model is eventual consistent. And we need to, and the conflict resolution is less writer wins. Considering all these pieces, the solution that we should provide to your customer is leveraging AWS Global Accelerator to redirect traffic across the region using an application load balancer. You can use, of course, EKS or ECS, whatever. But for the database where we have heavy writes and heavy reads with users connecting to multiple different regions and writing to tables that are distributed in different regions, DynamoDB global tables would be the perfect match, right? And because it provides out of the box support for conflict resolution, right? And that's one of the things we need to consider. Uh, let's say our second scenario is a relational database where we are heavy on reads, but not as heavy on writes. And we are kind of in between sensitivity to latency, and full consistency is required. And conflicts resolutions are kind of an issue to tackle. That would be a perfect match where it could be using Amazon Aurora global database with replication that is takes less than a second, and ECS and application load balancer and a global accelerator again, or even Route 53. And of course, with Aurora Global Database, we have reading locals, and we can write local with write forward in that a sub-second data replication across regions, no replication conflicts, configure read consistent model, session global eventual consistent. And we have at this point just single write instance, right? Just as a but again, speaking of Amazon Aurora, when we are not talking about multi-region, so let's say we are sticking to a single region, there are multiple ways to have multi-Z as well as multi-masters. So you can have multiple cluster instances receiving requests for receiving writing, inserting data and updating data at the same time. But at this point works only for within a single region. And this is a kind of scenario for the use case number two. And in a nutshell, this is the summary where you need to determine. So if you need the only disaster recovery, you can go with multi-region active passive. If you need data residence, you can go with something a bit more sophisticated, leveraging some mirror deployment. And if you need something even more sophisticated, where low latency user experience, you can go with DynamoDB global tables, Aurora global DB, and S3 cross-region replication. And also we have introduced the multiple access point for S3 as well. And just a few things to reminder when you are designing your multi-region active application, right? So just remember that when you need to go with active architectures that sometimes introduce or add significant complexity to your stack, so you need to think really carefully about your services and whether they need to be multi-region at all. So just keep that in mind. You need to eventually consider whether less complex multi-region architectures, like the ones I just told you, like a simple multi-region backup or a pilot light or even a warm standby can meet your needs, as opposed to go with a something more sophisticated but at the same time more complex. You need to think about carefully on how to design to avoid race conditions by using some of those strategies that I just mentioned, where we can have read local and write global, or partition it right, as I just explained to you in all of those scenarios. You need to use tools to keep data synchronized, including S3 cross-region replication, or even EBS snapshots cross-region copies. You can, of course, use DynamoDB. Uh, Consider also to use VPC peering to allow consistent security across regions. That's some of the things you need to consider. And some of the key takeaways. Uh, Remember, only use that as a first step. Multi-region activities help to limit the blast radius in case of major adverse events. And this is one of the key things you need to consider. But in order to simplify, try to minimize blocking dependencies between regions and minimize as much as possible synchronous replications between regions, and use graceful degradation in case of connection issues. And here are the few things you need to consider. And think about using inter-region VPC peering to manage your own replication, and and also to use the AWS backbone to use the replication. They are really straightforward, and they streamline the overall process. And try to use the cloud formation stacks as to manage the environment and to deploy across different accounts, as well as different VPCs at the same time and different regions. So using stacks as you can control how you deploy your components across the regions in a unified and consistent way. And before we can wrap up, I just wanted to remind you that AWS put together a checklist that outlined the top 10 components that make up an effective disaster recovery plan. And those key areas help to determine what your recovery object should be, and also what including infrastructure documentation, what should respond to an incident, and what their plan of action should be. I would strongly encourage you guys uh, if you have done have worked with this disaster recovery worklist at this point, because that would be key for you to determine what your RTO and RPO would be, and then as a result you can uh, came out with a list of uh, application tiers and which one should be put and should fall in each of the buckets to determine your overall strategy, and if you need to go with a pilot or a warm standby or eventually an active or even basically backup recovery would be enough. So that's are the key recommendation at this point. And I will provide this slide deck as well as to share the recording so that you can explore. Of course, there are uh, within the well architected, there are some of the labs you explore each of these concepts and fundamentals that I just explained, where you can work with this Aurora, global tables, or eventually you leverage some of the monitoring tools with CloudWatch as well as system managers to automate things. So I would strongly recommend to try to play with these well-architected labs to use to uh, get your hands dirty with the concepts that I just explained. And with all that said, I just wanted to thank you all for attending this session and see you in the next one. Bye.